Welcome to the show. I'm Jonathan, and today we look at the life cycle of stars. We are lucky to be alive, period, but also to be alive at this point in time because we know more about space than ever and have plenty of new things to learn in the next couple of years. But throughout all of time, everything on this planet, past and present, all of it is connected. So let's spend a moment to show some love to our sun and all the other stars in the universe by learning their life story. Stars are the primary source of raw material in the universe. They give us most of the elements on the periodic table. They recycle and distribute the building blocks of everything we see in the universe. New stars, nebulae, planets, and all living creatures, including humans. All carbon was created right in the core of stars. The size and mass of a star determines its life cycle and how many elements get shared across the universe. High-mass stars have short lifespans and eventually run out of fuel. Then their core will collapse in on itself. And once the gravity of this event isn't strong enough to contain the pressure, it will explode, sending out massive amounts of elements that ultimately recombine into new stars, planets, or asteroids. The size of stars is determined by the amount of matter that is in the nebula that forms the star. This is phase one, the high-density globule of gas and dust. The formation happens when hydrogen gas is pulled together by gravity and it begins to spin. It spins faster and gets hotter where it hits phase 2, the protostar. Reaching 15 million degrees Celsius, the materials falling into this protostar eventually stop where it settles into phase 3. Oftentimes, this process can last around 100 million years before reaching phase 4, the main sequence, where protons of hydrogen are converted into atoms of helium. It's the nuclear reaction where the star begins to release energy. This is where our sun is now. Releasing more heat than it needs, this energy gets released for around 10 billion years. For stars the size of our sun anyway. Eventually, the hydrogen fuel of a star can run out and the reactions stop. Once this happens, the star will begin to contract and expand. It will grow to a subgiant star and then a red giant, the red giant. Since the star isn't able to burn and heat up like it did before, it begins to cool. This is why it turns to the red color. At this point, the star is running out of hydrogen atoms that were being converted to helium. So the internal reaction stops and it begins to contract and expand where it becomes a subgiant star and then a red giant. There are many different sizes of red giants, and their next phase can go a couple different ways. Phase 6, fusion of heavier elements. During the expansion of the red giant, the helium molecules begin to fuse at its core, preventing it from collapsing. This goes on and on until iron is present, which causes a fusion reaction in the core where it finally collapses. The core implodes while the outer layer bursts out into space. For the stars the size of our own, it will calmly transition into a white dwarf, much smaller than its previous form and slowly dimming where it finally dies out to become a black dwarf. But if the star is much larger than our own, its life is very different. In the case of massive stars like this one, they will only burn for millions of years instead of billions. They are just too big to maintain a long life, but they have a really interesting journey. As they die down, they also become a red giant, or rather a red supergiant. It will hold this form for around 1 million years before it starts to collapse in less than a second. This creates an explosion called a supernova, where a shockwave blows off the outer layer, causing it to shine brighter than the entire galaxy. That's incredible. Throughout this whole episode, we are talking about millions and billions of years for things to happen, and then suddenly it changes in just one singular second. That's incredibly fast for the events of the universe. In some cases, the core of the star survives this intense galaxy-altering explosion and becomes a neutron star, roughly 1.5 to 3 solar masses. If it is larger than 3 solar masses, it contracts and becomes a black hole. Then there's the strange brown dwarf, which isn't really a star or a planet, yet has characteristics of both. They aren't massive enough to emit their own light, but are still toasty little hybrids. Astronomers estimate there are about 100,000 million stars in the Milky Way alone. And fun fact, we recently witnessed a red supergiant star collapse and explode into a supernova. But that's a topic for another episode, which is available right here As always, thanks for watching, and what did you learn today?